My name is Claire, and welcome to the SPICE program. I've created this collection of Python notebooks to help you get started on learning Python. These notebooks begin from the very basics of Python up to using some common libraries for initial data analysis. These notebooks assume no previous programming experience, but if you have some, you should get through these notebooks fairly quickly. But don't worry if you haven't ever had experience programming or you're very new to it. We should cover enough of the basics so that you can get some initial ideas on how to get started on your projects. And so first, I'll go over what really a Python notebook is and how to use it. So in case none of you have ever used Python notebooks before, basically you can have different cells. And so these cells can either be text or code cells, and you can add more cells by simply clicking either of these buttons. And so if you want to follow along and take notes, you can add some text cells and put your notes in them as you follow along with this tutorial. We'll be deleting these. If you have any code cells, what you can do is these cells are able to be run and compiled, and so they'll tell you if you have any errors with your code, or you can follow along with any of the programming exercises. We'll begin with our first Python syntax, which is the print statement. And so our print statement is pretty self-explanatory. You just have the word print with open parentheses and open quotes with whatever it is that you want to print. And they can be double quotes or single quotes. Python doesn't really care, it treats them the same. And so we can run these code cells, and the compiler will execute the command, and so we have our output, which is this hello. One thing to know about Python is that anything past the pound sign is treated as a comment. This is not read by the computer, and it will just skip it. So you notice that we commented out this print hello, so our output doesn't have the hello, we only have this command, the print hello world, and so here is our output. Commenting is really important because if you're working on a really large file or looking back at code you've written months ago, you can kind of like forget or get lost in your own code about what you were trying to do. And so commenting is really helpful because you can explain and write notes to yourself about what it was that you were trying to do. It's also good for your collaborators, so you don't have to like sit down with them and fully explain your code. Instead, they can try to track your thought process by reading your comments. It's also good for debugging to see if you want to try one line and it's not necessarily doing what you want, so you can comment it out. And so with our first Python command, we're going to talk about data types, because when Python reads in data, it assigns them what is known as a data type. And so for everything in the print statement, it is converting the output into what is known as a string data type. Here's a list of the default data types that Python will assign data. We'll go over some of the more basic ones. You don't need to know like every single one. So like I said before, text-based data is usually treated as a string data type, whereas we'll have ints and floats for when we're doing some basic math. So int stand for integers, which are whole numbers without a decimal, and floats are floating point numbers, which are any numbers with decimals. You can check the data type of any variable with this this type open parentheses, then your variable or the data that you want to look up the data type for. Data types are very important in Python because when we're getting into more of the different libraries and different methods that Python has, each one has an expected data type for your inputs. And if Python is, for example, expecting a int data type, but you gave it a float data type, it will return to you an error. And so it's important to keep track on what data type the data you're working with is. So we'll start with working with strings since they are the most basic and intuitive. And so, as I said before, strings can be written out with either the single quotes or the double quotes. It doesn't matter as long as you're keeping with the same one. So we have this variable called myDNA, which is just like a sequence of base pairs represented by this string. And so we're going to talk about indexing and slicing into strings. So an important thing to understand is that strings are represented to the machine as these arrays. And so arrays can be thought as like a collection of cubby holes. And each array has its own index. And Python starts counting indices from 0. Some languages start at 1. But it's important to know that Python starts at 0. So the first index will always be 0, the second index will always be 1. And so when we're slicing arrays, we're talking about the different indices. And so in this myDNA, you can see that we're just chunking off the first 3 characters of our string. Next, we'll cover some basic arithmetic operations so that we can get started with calculations. So here is a list of very basic mathematical operations that are built into just the basic Python. If you wanted to do more complicated mathematic operations, you would have to import a library. And we go over library imports later in later notebooks. So it's important to remember that the arithmetic expressions are always calculated in PEMDAS order, just the same as you would evaluate a mathematical expression. And so we can simply calculate 2 numbers by having these integers, and then we're adding them together, and then you can see that we have our output. Take some time to try to fill out the different other mathematical operations. Modulo is a unique one, so I recommend that you try using it first and kind of take a guess on what it's doing. After you've done that, I'll give you a quick explanation on modulo. So modulo actually returns the remainder of things. So For example, if I have 10 modulo 2, it will return 0 because 10 can evenly divide by 2. But if we're doing 3, it will return to you the remainder. And this can be good for example of checking if a value is even or odd, since if something is even, if we have the mod 2 again, it will evenly divide by that number, whereas odds will not. Briefly, we'll go over variables because sometimes you don't want to just be recalculating these numbers in your code. You want to actually be able to reference them. And so we can assign a variable by just having a name for your variable, which can essentially be anything. We'll go over what you cannot name a variable, but you can essentially name variables whatever you want, and then you use the equal sign for assignment, and you can assign it to whatever your data is. So in this case, we're just having the integer 15, and when we run this and we can check the type, it will say that this 15 is an integer. If we want, we can make it a float, and then it will return that it's a float. What's really nice about Python is that you do not need to predefine the data type. Python will assume the data type based off of the data that you are giving it. In other languages like Java, you actually, as part of creating the variable, you actually have to say what data type it is beforehand. And so this is what the syntax would be in Java instead of just the var equals 15. Since now we have this variable in our computer's memory, we can use it later on in the code. And so we have this var plus 2. Notice that because I changed it to a floating point number, it will actually keep the decimal point. If I wanted to change it back, I would just have the, I could typecast it. So we can typecast by basically just having the data type that you want, open parentheses, and we're putting everything in. And so then it will print out as just 17 because it's converting the data type. Here's an example of when Python will return to you an error. So this var2 we have not defined anywhere in our code. And so when we run it, it will throw this error and tell you that this variable name is not defined. It doesn't know what this variable is or what value it should have. And so this is a good way of learning how to debug and keep track of your Python errors. So usually you just need to read the last error that is given, and that will kind of direct you to whatever is the problem. And so how we would fix this is that for us to define what var2 is equal to. And so now this will compile to equal 6. Another thing is that certain operations cannot work together. So if I make var2 a string, it's not going to add 2 to a string because it's expecting either some kind of numerical value. And so then it will give you an error that you have a type error. And this goes back to what I mean is that certain operations have an expected data type that they're working with. And so if your types are incorrect, it will give you a type error. It's saying it's expecting an int and it cannot use the detected string. So I get a lot of questions about what is like a good naming convention for your variables. And so in general, you want to have informative names to your variables. So actually our variables that we've been using previously are not good variables because they are not, they don't give you like explanatory power on what you're trying to calculate. So we want to name our variables based off what information that they represent or what they're calculating. So a more informative variable would be something like this. We have a data underscore CSV for when we're reading in a CSV file called KK's data. A common programming practice is that we tend to name variables in what is known as camel case, which is to start with a lowercase followed by each uppercase for each word. So instead, we could call our variable KK's data file, with data and final being capitalized. Some people use underscores instead. What is just important to note is that spaces don't work because Python will read these as separate variables. So you have one variable called KKs and one variable called data and one variable called file, which is not what you want to do. At the end, we have a table for words that you cannot name variables after. That's because these are known as reserved keywords and are used for Python commands. So understandably, you wouldn't want to name a variable after a built-in Python command because then Python will get confused on are we referencing a variable or are we trying to do some kind of action? And so Python will let you know that a variable is a reserved keyword, but in general, you want to, again, just have informative variable names. Python is also particular about what your capitalization is. So for example, for false, it's the reserved keyword is specifically just the uppercase F with the lowercase ALSE. And this is also important for when you're referencing variables. So a lowercase var2 is different than an uppercase var2. And these are just like important things to note when you're programming. So for some homework, you can try out these exercises on Rosalind. I've linked over here. The initial ones you should be able to cover with just the materials that we've gone over here. So just these covering variables in arithmetic, which we've covered in this notebook, and some strings and lists. We've covered very basically on how strings work, and we'll go over lists in the upcoming notebooks. But functionally, they can be very much treated the same. So thank you, and see you in the next notebook.